We are officially on. Okay, so we have covered a lot of stuff this year. I mean, we've covered kind of the vast majority of Algebra 1 already with you guys, with one exception. We have not talked about quadratic equations. Quadratic equations, if you turn around and look at that poster back there, quadratic equations are the ones that say y equals x squared. What shape is that? Does anybody know?
Parabola.
It's a parabola. So we are going to be talking about parabolas. And so Nathan, heads up. Okay, pass it back to me. Okay, Adam. Okay, pass it back to me. Okay, Kareem. Okay, somebody pass it back to me. All right. Nice throw. Okay, Elizabeth. All right. Okay. So why am I doing this? Okay, Sakara. Watch this. Watch this, guys. Nice catch. All right, Sal. Okay. What's different about the throws I'm making? I didn't, you're right. Ceiling. What am I creating when I do that? A parabola. Every time. Good, right, exactly. Every time. Every time you throw a football, you have created a parabola. Every time you shoot an arrow in the air, you've created a parabola. Every single time you shoot a gun, right, at a target, you're actually, it's not going straight. It's going up a little bit and down a little bit. It's a parabola. And parabolas are what we're going to discuss. And we're going to discuss, in particular, something called the quadratic formula. It is probably the most important or most famous formula in algebra. And it's one of the it's one of the most famous formulas on the planet. I mean, it's really, really helpful and important. Now, let's first of all talk about it before I actually unveil the quadratic formula. And I'm going to just say something. I've never taught it this way before. I've never taught as the introduction to quadratic equations to teach the quadratic formula. I've always taught the quadratic formula at the end. But I'm going to try something new with you guys. I think it's kind of exciting. And you'll see why in a few minutes, or at least I will see why in a few minutes. But first of all, I want you to understand a couple things. We've got to have a few foundational things. First of all, I'm not going to write the quadratic formula. I'm going to write a quadratic equation. Equation in standard form. This equation is this. Y is equal to ax squared plus bx plus c. Okay? Now that's in standard form. Standard form now looks very different than the standard form we know for straight lines, right? The standard form for straight lines would be ax plus by equals c. Remember that? The x and the y are on one side of the equal sign, and then the plain old number is on the other side. This is totally different. So, but it's also called the standard form, but for quadratics. Okay? Now, when you have this equation, the y is always a y. The x's stay as x's. But the a is actually a number. That's a number, the b is a number, and the c is a number. Okay? Those are all numbers. This is just sort of to show you the format of a quadratic equation. Okay? Now, when you have a quadratic equation, you can graph it, and it will graph in two ways. You can graph it You could graph it like this, where it has a happy smile, right? You could graph it,
Make it sad.
or you could make it sad. You could have something like this,
And draw some eyes.
right? You could also have one that go, let's see.
That has a creepy, twisted, destroy all your hopes and dreams smile.
You could also have one that's, so notice these two cross the x-axis, right? Right? But you could also have some like this where they never cross the x-axis.
Can you make some more curvy?
Or you could have another one down here where it never crosses the
Can you have
x-axis.
sideways problems?
No, you cannot have a sideways. I mean, you can, but that's not what we're talking about, right?
Can you make them more curvy?
Because
like
we are actually talking about functions. Do you guys remember functions a little bit? And what's the concept of a function? A function says that for every x there can only be one y. Did we cover this? We talked about this, right? For every x there can only be one y. So if I'm going, did I talk about the vertical line test? The vertical line test always shows you whether it's a function or not, because if I have a vertical line and I move it across a graph, the line can only touch that vertical line in one place. So look, it starts touching right there, there, just in one place, right? It's only in one place, so that is a function. However, if I did this, if I had a parabola like that, look what happens. Right here, it's only one place, right? But as soon as I go past that point, now suddenly it's touching this vertical line in two places. That's illegal for it to be a function.
Oh, I get it.
So we're talking about parabolas that are functions. That's what I'm talking about, okay? All right? So we will not be dealing with these kind of things. We'll only be dealing with these kind of parabolas. They're either happy face parabolas
If your line is short.
or sad face parabolas. Now, there's one thing that's helpful to know in terms of happy face and sad face. If a, the number in front of x squared, is a positive number, positive, happy, I love it, right? So that would be a happy, positive parabola, right?
Wait, if the number
So,
is what?
for example, if I had y is equal to 2x squared plus 3x minus 7, that is going to be a happy parabola because it's a positive 2. Isn't that great? Okay. So, but if you had y is equal to negative 4x squared minus 8x plus 2, it's very sad. This is going to be a very sad parabola, right? Very negative. Negative thoughts, sad, bad, right? Positive thoughts, happy, good, all right? So you got that? Okay. All right, so I guess I don't have to erase anything yet. When you have a parabola, a lot of times, like when like if I'm shooting an arrow, right, and I know, let's say it's been determined that the arc of the arrow would be modeled by a certain formula, such as this or this. Well, actually, it would be more like this, because remember, when you shoot an arrow, it's a sad face, right? It's going to be a sad face parabola, right? Whenever you throw a football or a marker or anything, it's going to be a sad face, so it's going to be a negative A, right?
What if you bounce a ball? That's a happy. No, that's not so sad. It's kind of both.
Well, when you bounce the ball, you're actually creating a negative parabola, because it's going to bounce, it's going to come up, and then it's going to go down again, right? It's gonna.
Well, if you drop it though, it goes down and then back up. Oh, was it a yo-yo?
Right.
But if you throw it, it goes down and then it goes. Yes, but if you're just holding it,
I see what you're saying.
and then comes back
I see what
up.
you're saying. So yeah, technically, I don't know. That'd be interesting. I hadn't thought of it like that. The only problem with that is that because of gravity, I think it would interfere with the actual arc. I think. I'm not sure. I'd have to play with that. It's a good question. Because coming down it would be accelerating, right?
Yeah.
Then, but going up, it's going to be decelerating. Whereas typically, if you're decelerating, accelerating. I guess I don't know. Maybe it would be. I guess it would be. Yeah.
Accelerating going down.
Yeah. So anyway, so what's important though is a lot of times you're wanting to know if you shoot the arrow here, you want to know when is it going to land on the ground here, right? So basically, finding your x-intercepts is a very, very important thing with quadratics. And notice there's often more than one intercept. There actually could be two intercepts. This is an example of two intercepts. Another example, this red one, of two intercepts. What's this an example of? No intercepts.
Whoa.
Right? So when you're solving a quadratic equation with this, with say this particular equation, it would actually be unsolvable. You'd actually get a negative. Well, we're not there yet. Anyways, it would be undefined basically. Same with this one. Now, there's one other kind you could have. You could actually have a parabola that does this, and it turns right here, and then it goes back up again. How many places does that hit the x-axis? One spot. So you could have one spot, two spots, or no spots, where it crosses the x-axis. So what we're going to look at now is the quadratic formula, the famous formula, and we're going to see how to use it. I'm going to erase this. It's one of these formulas that if you know it and you can say it, from memory, which you all will be able to, you will impress your parents. You will impress everybody because it's such an amazing formula. Okay, here's the quadratic formula. The quadratic formula. Okay. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So write that down.
X equals negative 2 plus or minus square root of b squared minus 4ac.
Wow, you're good at reading,
Yeah.
Sal.
Okay,
So that is a valuable formula. Now, as you start to see how I use it, you're going to freak out a little bit, right? I'll just tell you right off the bat.
you have to write the square root of b squared.
Yeah, you're right. Square root of b squared. Minus 4. You can't, for this part, you cannot, just so you know, India, you can't take the square root of b squared separately of this. You know what I mean? You have to find your total value. All right. So let's say we want to find the x-intercepts of this equation. Let's try it. I don't know what it's going to be like. This came out. I just wrote this kind of quickly, so we'll see how it works. So this is my A. Remember, it's y. Okay, this is the A, this is the B, and this is the C.
Whoa.
Right? Now, it's important to realize, though, that the signs in front of the numbers are part of the numbers as well. Okay? So you've got to. So I'm going to say over here. I'm going to say my A is equal to what? 2. My B is what? 3. And my C is what?
Negative 7.
-7. That's really important that you put a -7 there. Very important. Okay? So now what I have to do is I have to write this formula Only with these, I have to substitute these values in for this formula. Now, when you first try it, and you first see it, you freak out and you're thinking, oh my gosh, this is so much work, right? It's so much work. Well, you know what? After a while, it becomes quite simple, So, let's try it. So x,
plug those in, right?
we're going to plug it in. X is equal to negative b. So I'm going to put negative 3 plus or minus the square root of, b squared, which is 3 squared. I'm going to write it this way, 3 squared, minus 4, and then it's a times c. Now, I do not recommend you multiply it out in your head right now. I recommend you write it out. That's what I'm really asking all of you to do. 4 times 2 times negative 7. All right? All over 2 times 2.
What is that weird plus thing?
That's called a plus or minus. And basically, that is the reason why you could potentially have 2 answers.
Wow.
And you'll see in a few minutes. You'll see in a few minutes.
Where are you?
I'm going to do, this one I just made up out of my head. I'm going to actually do some after this one. This is sort of your introduction one. But I'm going to do some that are a little simpler so that you can see them, see how it works a little bit. But we'll just see how this works. So I'm going to simplify this. So I'm going to say equals. I'm going to say that's negative 3. That's pretty simple. Plus or minus the square root of, now I'm going to do this. 9. Okay, now look. I've got a minus times a plus. That's minus. But a minus times a minus is a plus. Minus times positive is negative. Negative times negative is positive. So I'm going to say plus. Now I just multiply the numbers. 4 times 2 is 8. That's 8 times 7. 56. All right. All over 4. Now I'm going to keep going. I'm going to negative 3 plus or minus the square root. What's that? 65? Am I right?
Yeah.
65. Okay. Over 4. That is my answer.
Oh.
Is that weird or what?
That is
That-
kind of tricky.
Now remember though, so that means x is equal to that. Now if I wanted to graph this and find my x-intercept, those are my x-intercepts. The trouble is 65 doesn't have a perfect square root.
No.
But I could get out my little calculator. With the quadratic formula, it's really helpful to have a calculator. Okay? Really helpful. But I could get out my calculator, I could write 65 square root. And that'll tell me what that is. And then, let's say, so 8 times 8 is 64, right? So we know it's going to be around 8, right? So it's going to be, so it would be, let's just call it 8.1, right? For simplicity. So if I wanted to know the actual number, this is what I'd do. I'd say negative 3 plus 8.1 over 4,
8.3.
or, see that or there? Or negative 3 minus 8.1 over 4. And I would use my calculator to figure that out. And I'll have 2 answers. Does that make sense?
Yeah.
So that's an example of one where it doesn't have a real clean-cut final answer. I mean, there's the square root of 65 doesn't have a perfect square root. It's not, it's not a perfect square. So all your answers are going to be approximate. Now let's try one that's a little simpler that will actually solve, right? We'll actually get a final answer.
Okay.
But the thing is, the reason I gave you this one first is I want to explain this. The quadratic formula always works. It works for everything that is a quadratic equation, okay? And so you can always use this. Now, I've always taught this at the end of my quadratic, classes. because I teach other things first. There are ways to factor things, factor these to find the x-intercepts that are very quick and easy if they're easy problems. And so you try those first. You try those other ways first, but if you don't see it right away within the first 10 seconds, you don't see the answer or the way to solve it or to factor it, then you go right into your quadratic formula. And I'm teaching it first now because I want you guys to get really comfortable with it. Because if you are comfortable with the quadratic formula, you will be way ahead of everybody else in your class in 10th grade. Guaranteed. Because most people, this is the stuff that people don't learn very well, the quadratic stuff. And if you learn it well, you will be way far ahead. First of all, x is equal to negative b. Repeat after me. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, again, x equals negative b plus or minus this b square root of b squared minus 4ac all over 2a. Okay, who can do it?
Me.
Without looking. Okay, Sal.
Okay, x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a.
Awesome. Who else can do it? Give him a round of applause. That was awesome. Okay, anybody else? Sal. Nathan.
So x equals negative b plus or minus the square root of b squared plus 4
Minus
plus minus 5
minus 4.
4ac all over 2a.
Awesome. Well done. Good job. Anybody else want to try it? All right, Gabe.
Negative b plus or minus the square root of b what is it?
B squared
b squared plus
minus.
You're
right. Keep going.
minus
4.
yeah 4
Yes.
AC.
Yes, that's it. All over.
2a.
Awesome. Very good. Awesome.
Yeah.
All right, so now we're going to do one. So you have to memorize this, guys. Everybody has to memorize this. Now we're going to do one that's a little simpler. Let's try this one. Let's say y is equal to, actually,
Minus something is equal to something minus something.
One thing I sort of want to explain too is that, okay, so let me just write this first. So x squared plus 3x plus 2. All right.
So basically,
This is
the
our
y in
next
front
one.
of the x squared,
So what is the a
equals
here?
0.
A is, no, it's not 0. If it's 0, then that wouldn't exist.
1.
If it was 0, that wouldn't exist, right? It's 1. All right? All right, what's B? B? 3. And what's C? 2. Okay, so one thing I didn't explain is to solve using this formula. So write this down because this is really important. A quadratic must equal 0. Maybe I shouldn't do that line in there. That's like theta. Sorry. Must equal 0. Okay? So when I'm finding because think about it, when I'm finding the x-intercepts, what is y?
0.
Y is 0, right? So basically what that means is I'm actually going to make it equal to 0. So I'm really doing this. I'm doing x squared plus 3x plus 2 equals 0. Right? You with me?
Yeah.
Now what though, let me just play with this for 1 second. What if I wrote it like this though? What if I said x squared equals negative 3x minus 2. What would you do? It has to equal 0. It doesn't equal 0.
Well, if you subtract
Minus x squared.
x squared from one side, and
Then I'd have a negative x squared. I don't want to do that. I want it to say positive x squared.
You subtract negative 3x minus.
I would add 3x and add 2 to both sides, right? I could get it, add 3x to this side, add 2 to this side, add 3x to this side, add 2 to this side, and then I get x squared plus 3x plus 2 equals 0. You with me? You'll have to do that on the homework tonight, okay? A little bit. Now let's do it.
homework now. Wait, Gary.
All right, so now let's do this problem.
No, we'll do it first.
And then I'm going to pass out the homework, okay? So, here we go. X, this won't take very long. You'll be amazed. X is equal to negative b. B is 3, right? So negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 2. Right? You with me? All over 2 times 1, which is just 2. All right? I'm going to just redo it now, simplify it a little bit. Plus or minus the square root of 9 minus
Doesn't the 2 have to be squared though?
9 minus 8 all over 2. Now that is the same as negative 3 plus or minus the square root of 1 over 2. Ah, what's the square root of 1? Is 1 a perfect square?
Yeah.
Right, square root of 1 is 1. So I can get rid of the square root. Oh my gosh, this is great. So that means I've got negative 3 plus 1 over 2 or negative 3 minus 1 over 2. So I'm going to have two answers. So
You
it's
have to give me both the answers.
and I want both the answers. So this is, what's negative 3 plus 1?
That'd be 4. Or no.
If we wrote negative 3 plus or minus 1.
Wait.
What's that
What? No. So you can't leave it now. You actually have to give me, once it comes out of a square root sign, I actually need the final answer for each of them.
Negative 2.
Right? So negative 3 plus 1 is negative 2, right?
Yeah.
Negative 2 divided by 2 is
Negative 1.
negative 1. So negative 1 or what's negative 3 minus 1?
Negative 4.
Negative 4. Negative 4 divided by 2 is
Negative 2.
negative 2. So those are my two x and my two x-intercepts. So I know that when I graph this, negative 1, negative 2, I know that there's going to be like there and there. So, and it is going to be a smiley face. So it's probably going to look like that. Somewhere like that.
Cool.
Okay? So it's just going to take a little getting used to. This will become one of your greatest friends in Algebra 2, believe it or not. Because it always works. There's very few things, you know, in algebra or in math where you know it always works. This is gold, right? So I'm going to give this to you, this homework, and I want you guys, there's only 6 problems. They will, I believe they will all work out so that the square root will actually come out. You'll get rid of the square root. So you'll give me 2 answers, okay? Does that make sense? So that is,
Negative 7 or negative 7.
and try to memorize it. I want to see how many people know it by tomorrow, or by heart.
I'm sure
All right?
a lot of the time.